This video is on significant figures in measurements, and we often refer to significant figures as sig figs. You will hear me use that term quite a lot in addition to other chemistry teachers or chemistry professors. So this video will be on what exactly is a significant figure and how to read measuring devices like rulers, graduated cylinders, thermometers, things like that, to the correct number of significant figures. And then there will be a second video on how we use those significant figures in measurements. Pardon my dog. Okay, so before we discuss really what a significant figure or a sig fig is, you have three rulers on your paper. And of course they're made up rulers. And so I would like you to jot down how long you think the three different nails are with the three different rulers. So just take a couple seconds and jot down what you think. And then I will come up with some answers that I think students may have also come up with if we were in person. Okay, so all right, so maybe this first ruler, maybe you said 4 centimeters, maybe you said 3.5 centimeters, maybe you said 4.75 centimeters. Okay, I don't know. There could be a plethora of answers that students would give. Okay, in the second one, I'm going to guess that maybe students said 5.5 centimeters, 5.3 centimeters, 5.75 centimeters. We'll stop there. And then in the third one, maybe 6.4, 6.5, 6.45. Okay. All right. So it doesn't matter if your answer, if any of your answers match those or not. So that's kind of, not the point. So before we go back and have that discussion, I want to define what significant figures are. Okay. So they are this. They are all the known digits plus one estimated digit in a measurement. Okay. And there are a couple important words here. Known and one estimated. Okay. So significant figures are defined as all of the known digits plus one estimated digit in a measurement. Okay, and we'll come back to that idea in just a minute. So if we go back to my ruler, this first ruler that we had, and what we're thinking about is what do we know for sure about the length of this nail? Okay, so basically, because this ruler is horrendous, the only thing we know for sure is that its length is greater than 0 and less than 10, right? That's all we know for sure. So we don't really know anything for sure. So basically, what have we done in this whole scenario? We have estimated, okay? So when we estimated and said, oh, I think it's 4, right? That's not known to us at all. We're estimating. When we estimated and said, I think it's 3.5, this 3 is not known at all. It's estimated. And same thing with the 4 and 4.75. So all those digits that I underlined in green, I did green because I had down here said that they're estimated. Okay, so if you read the definition again, that a sig fig is all the known digits plus one estimated digit, that what this means is we can only have one estimated digit. So you might want to write that. Can only have one estimated digit. So once you pass more than one, you have to stop. Okay, that's how this works. Once you hit one estimated digit, you have to stop with your measurement. So based on what I just said, this number 3.5 has 2 estimated digits, and I can't have that. And my 4.75, goodness, has 3 estimated digits, and I can't have that at all. So in this group of answers, the only one that would be acceptable would be 4 centimeters. Now, but maybe you're saying, well, but I thought it was 3 centimeters. That's fine. Okay, because 3 centimeters still has only 1 estimated digit, and that's okay. Even if you thought it was 2 centimeters, okay? But you couldn't have any more decimal places in this case because all, my 3 and my 4 in these 2 answers are estimated, and I can only have 1 estimated value. So let's go to the next one. Okay, so in this case, what did I know for sure? Well, hopefully we knew for sure that this nail was greater than 5 and less than 6, right? Because these markings are ones, so this is 6, 7, 8, 9, and then 10 centimeters. So what do we know for sure? That the nail is bigger than 5 and less than 6, so it's got to start with 5, right? So this is a known value, this is a known value, and this is a known value. Okay, so now, though, I don't know anything else for sure. So everything from here on out is an estimated value. So is it okay to say 5.5? Sure, 1 known value and 1 estimated value. That's fine. Somebody else thought it was 5.3. That's okay because it's an estimated value. So these 2 numbers are fine. But my third one, 5.75, I have estimated the 0.7 and then I've estimated a second time. And so that one is not good because it has 2 estimated values. So hopefully this is making a little bit of sense. And we just have to keep referring to this definition that says all known plus only 1 estimated. Okay, so in this third ruler, first we have to figure out what these markings are. Right, well, this is 0.5. And so these markings are tenths. So this is 0.1, 0.2, 0.3, 0.4, 0.5, and so on and so forth. So what do I know for sure? Well, I definitely know that this nail is between 6 and 7 centimeters. So this is known, and this is known. There's no doubt about that. I also know that this nail is between 6.4 and 6.5. So 6.4, that's a known value. 6.4, again, is a known value. Now, whoever said 6.5, I don't think it's 6.5. It's not there yet. It's not to here. So I think this number is just inaccurate, not based on sig figs, but based on the reading of the measuring device. Okay, but I don't have any estimated values yet in 6.4. So if I stopped here, which some of you maybe had done, that doesn't contain an estimated digit. And to be a sig fig, you have to have an estimated digit. So this number doesn't have enough digits. Whereas 6.45, that 5 is in fact estimated. And so 6.45 is an acceptable answer. Is it the only acceptable answer? Absolutely not. Maybe somebody else thought it was 6.43. Okay, it's perfectly acceptable. Maybe somebody even thought it was 6.48, right? That's okay. You might say, no, it's not. But, these last values are all estimated. And so it's kind of what you think the number is, okay? So I hope that made a little bit of sense to you in terms of the definition. And again, we always go back to this. Okay, this is the bold idea or the takeaway point that significant figures are all the known digits in a number plus 1 estimated digit. And then, of course, you can only have 1 estimated. Okay, so we'll do a couple more examples with a couple different pieces of instrumentation. So this first one is a graduated cylinder which holds water. And we'll be working with graduated cylinders in class. Now, when you put water in a cylindrical shape, it curves a little bit. So I tried to kind of draw that for you right here with the curve of the water. And this has a special name. Oops. Some of you may know it. It is called a meniscus. you have a meniscus in your knee, but when water takes a curved shape in a cylinder, it's also called a meniscus. And when we read the volume, this is important, we read at the bottom of the meniscus, okay? So we're gonna read the volume right about here. Okay, so we're gonna go back to my idea of what's known and what's estimated. Okay, so I definitely know it's somewhere between 35 and 40. I'm going to start with my 3. Let's see, these are 1s, so 36, 37, 38, and 39. So I also know that it is between 36 and 37. So I have 2 known, I think known was blue, right? Yeah, I have 2 known values here, and so to make this number accurate, I need an estimated value. Okay, so again, I'm reading at the bottom of the meniscus. Again, it's estimated, so whatever you think. I mean, I don't know, 36.4 milliliters. Okay, and that's fine, but this is the estimated place. So maybe your lab partner read it and they thought it was 36.1 milliliter. Okay, that's okay, because in terms of sig figs, you still have all your known values plus an estimated place. Okay, so takeaway here, we read at the bottom of the meniscus, all known values plus 1 estimated. Okay, the second piece of glassware is a burette. Burettes are very skinny, very long ways that we read volumes of water. The one weird thing about a burette, though, is that you notice the top measurement is 0. So if this thing was full, it would read 0 milliliters, right? That seems funny to us. And there's a reason for that. We'll get into that at another time. But we still read a burette exactly like we just read the graduated cylinder. Nothing different. Okay, so we read at the bottom of the meniscus, and we're thinking about how many known and estimated values we have. So what do I know for sure? Well, I know this volume is between 0 and 1, right? Bigger than 0, less than 1. So 0 point. Okay, so what else do I know? Well, let's see. This is 0.5. So these are tenths. So 0.6, 7, 0.8, 0.9, and then 1. So I know that bottom of the meniscus is between 0.6 and 0.7. Remember, we read at the bottom. So this is definitely 0.6. So this is my known value, right? And then now I need an estimated value. So you estimate. If you think it's 0.65 milliliters, that's fine. Maybe your lab partner thought it was 0.68 milliliters, right? That's fine, because again, known value, estimated value. Okay, so that's how you read a burette. I know it seems funny because you know there's way more than 0.68 milliliters in there. There's a reason for that, and we will discuss it at another time. Okay, last one is a thermometer, and I did this on purpose. So it's a Celsius thermometer. We want to know the temperature to the right number of sig figs. So what do we know for sure? Well, it's between 20 and 25, right? So it's definitely 20 something. What else do we know for sure? Well, these are ones. So 21, 22, 23, 24, 25. Normally we say, oh, it's between, 23 and 24 or whatever. But this time, at least in my opinion, I think it's exactly dead on at 23. And it's possible that that could be the case. So if you record 23 degrees Celsius, you have not recorded an estimated place, because what you're saying is it's directly on the 3. So how do you record an estimated place without changing the value of the number? You would record it as 23.0. And what you're telling your reader is that you're confident in the 23 and that you've technically estimated the 0.0, but that it's dead on at 23. Okay, so that might be a little bit confusing. The weird thing about this example is that you have always been taught in math class that 23 and 23.0 are the same thing. And they are, okay? Technically, the value of that number doesn't change. Your calculator reads 23 and 23.0 as the same number. The difference is that now in chemistry, 23 and 23.0 have different numbers of sig figs. We could read those devices differently. And so we now say there's a difference between those two numbers. And so that's what sometimes throws students just a little bit, in that technically now 23 and 23.0 are different due to the number of sig figs.